Hi everyone, welcome to today's video where I'm going to be talking about some of the different types of intermolecular bonding and how that is related to whether or not molecules are polar or non-polar. If you are not confident yet with polar and non-polar, please go back and have another look at those videos first, because the different types of intermolecular bonding are not going to make a lot of sense until you're clear on polarity. Okay, so in year 12, level 2, you will have learnt that there were 4 basic types of bonding that occur between particles in a substance. So you get ionic bonding, which occurs in ionic compounds, metallic bonding, which occurs in metallic compounds. You have covalent bonding, which occurs between the atoms in a giant covalent network. And within molecular substances, you get 2 different types of bonding. There is the covalent bonds that exist between the atoms in the compound, and then there is the intermolecular bonding, which occurs between the molecules. And the intermolecular bonding is particularly important, and that's what we're going to be focusing on in this video. So, the intermolecular bonding is the attraction between molecules. Now, they can be 2 molecules of the same type, or they can be 2 molecules of a different type, which is particularly important with solubility. So, for example, if we're looking at a solution of water, well, a container of water, then we're considering purely the interaction between the water molecules. If you're considering the solubility of a different substance in water, then you'll be considering the bonding that occurs between that substance and water molecules. Okay, so there are 3 basic types of intermolecular bonding, all of which are related to different types of properties. So we have what is first known as instantaneous or temporary dipole-dipole attractions. These are also known as London dispersion forces or van der Waals forces. We typically, in NCEA, we prefer the phrase temporary dipole-dipole attractions. We also have permanent dipole-dipole attractions and hydrogen bonds. Now, just a reminder, a dipole occurs when a molecule has a positive part and a negative part. So those 2 parts, the positive part and the negative part, are known as the dipoles. Okay, so dipole literally means 2 poles, a pole being a positive and a negative. Okay, so the first one, which is probably the most confusing for everyone, is temporary or instantaneous, or sometimes known as induced dipoles. Now, every single molecule, polar or non-polar, has this type of intermolecular bonding. It is generally relatively weak, but every molecule has it. So what happens is, as 2 molecules are floating around, whether they're in the air, in a liquid, in a solid, as they're moving, when they come close to each other, one molecule, well, they have these electron clouds, and the electrons in that electron cloud are always moving. And as one molecule comes close to the next molecule, the electrons will sometimes form slight regions of positive or negative charge as they're moving around, so they're not always totally evenly distributed. That can then induce a dipole on the neighbouring molecule, which is very temporary, doesn't last for very long, but we've got these temporarily induced dipoles, which then attract each other. So this is very short term, but it happens a lot. So here's an image. Okay, this is looking at a bromine molecule. And on the left-hand side, you can see what happens over time is that the movement of the electrons evens out. So the electrons are evenly distributed across the molecule. That's why it's all kind of the same color. But for fractions of a second, what can happen is that the electrons may accumulate in one area or another. When they accumulate in an area, that area becomes slightly negative for a fraction of a second, an instant. One area is slightly negative, one area is slightly positive. The slightly positive area might attract some electrons on the neighbouring molecule, which are going to pull over, so it'll give some attraction, very short term, before moving away again. Now that is enough over time to cause sometimes some quite significant attractions, because as you get bigger molecules with bigger electron clouds, you get more frequent and larger temporary dipoles forming. Okay, so although these temporary dipoles are quite weak, they are influenced by two things. The first one is the size of the molecule, so the size of the electron cloud of the molecule more precisely. Larger electron clouds mean that there is a greater chance of electrons accumulating in one area or another at any given point in time. Small electron clouds, things like hydrogen or helium, it's only got a couple of electrons, they can avoid each other quite nicely. You get up to something like iodine with 53 electrons, they're bouncing around, they're going to be coming into contact with each other more frequently. The other thing is the shape of the molecule. So a linear or planar molecule, so something that's long and straight, or sort of sausage shaped or flat, is going to have more contact or surface area than a spherical molecule. That's important because if we're thinking about these dipoles being induced from one molecule to the next, the more surface area or contact area that's contacting neighbouring molecules, then the more likelihood, or the greater the likelihood of these induced dipoles forming. Okay, so this is the first type of intermolecular bonding, and it is very common. It happens in every single molecule. Okay, permanent dipoles are probably what you think of most when you think of intermolecular bonding, and this is the attraction between positive and negative ends of polar molecules. So any molecule that's polar will have part of the molecule which is positive and part of the molecule which is negative. And so the negative part on one molecule attracts the positive part on the next molecule, which attracts the negative part on the next molecule, and so on and so forth. And so we get these attractions. And these are known as permanent dipole-dipole attractions because they occur between the dipoles of neighbouring molecules which are permanent. For example, hydrogen chloride or hydrochloric acid is a polar molecule. Hydrogen is slightly positive, chlorine is slightly negative, and so the chlorine on one molecule will be attracted to the hydrogen on the next molecule. So that's probably the most obvious one. Now, hydrogen bonding, which is the third type of intermolecular bonding, is a subset of permanent dipole interactions. Okay, so it's the bonding that occurs between molecules where hydrogen is bonded to a very electronegative atom. In this case, we're talking only nitrogen, oxygen, or fluorine. Because nitrogen, oxygen, and fluorine are the three most electronegative elements on the periodic table, the bonds that they form are the most polar bonds that you can get on the periodic table. Because they are the most polar bonds, they form the strongest intermolecular forces of attraction, which are so strong that they're actually given their own name, and that's hydrogen bonding. So here, if we have a look, what I want you to note on this is that the hydrogen bonds are the intermolecular bonds. They're not the bonds between hydrogen and oxygen. They are the intermolecular bonds, the bonds between the molecules. So they're just like permanent dipole-dipole forces. It just happens to be with ones that have hydrogen in them. That's all. Okay, so to sum up, all molecules form temporary dipoles. All polar molecules have permanent dipoles, but only molecules with a permanent dipole and a hydrogen bonded to nitrogen, oxygen, or fluorine will form the intermolecular hydrogen bonding. I like to think of this almost like as a Venn diagram. So if you like Venn diagrams, great. If you don't, feel free to ignore the next slide or so. But if we consider all molecules have temporary dipoles. Okay, so that's the temporary dipoles. Then we have our polar molecules, which have temporary dipoles and permanent dipoles. And finally, we have our polar molecules that have HF, HO, or HN bonds, and those have permanent dipoles, temporary dipoles, and hydrogen bonds. Okay, so in the next video, what I'm going to be looking at is how we go about identifying what type of bonding is present, comparing the strength of the bonds and relating it back to the properties. I will see you then.